All right, so here, number one, we have three parts. The first wants us to find the degree and the y-intercept, and we want to express the intercept as an ordered pair. All right, so one of the first things you should notice is that this polynomial is already in a factored form. So you can't simply look at it and look at the biggest exponent and write down the degree. So this is what you want to do. First, let me write this out. F of x is equal to x plus 3 to the second power, and then we have x minus 1 to the third power, and then we have x minus 2. All right, so when it's in factored form, the way that you find your degree is you just count up all the x's that you have. All right, so we have 1 here, and then here is to the third power, so that counts as 3. So we got 1 plus 3 gives us 4, and then plus 2 more gives us 5, 6. So this, when we multiply it out, would give us a 6-degree polynomial. So I'm going to say degree is 6, and then you want to find the y-intercept. So remember, when you want to find the y-intercept, x is 0. So we're going to plug a 0 for x, and we're going to solve it. So I'm going to have 0 plus 3 squared, and then 0 minus 1 cubed, and then 0 minus 2. So you just plug in a 0, and then you can solve it. You can also just plug this into a calculator, and then you can see when x is 0, which I'll show you how to plug it in the calculator as well if you have that. So 0 plus 3 is just 3, so we're going to have 3 squared, and then 0 minus 1 is negative 1, so we're going to have negative 1 to the third, and then 0 minus 2 will just give me a negative 2. So we're going to be multiplying all these numbers. 3 squared, 9, negative 1 cubed, negative 1, and then times negative 2. So this is going to give me a positive 2 and then a positive 18. So the y value is 18, x is 0. As an ordered pair, that would be 0, 18. So that's what you would want to do to get the y-intercept. And again, all of these, if you want to speed up that process, you can just type them in your calculator. Go to y equal. I'm going to clear out what I have, and I'm just going to type this polynomial as it is here. That is x plus 3, close parentheses, squared, and then x minus 1, close parentheses. We're going to raise that to the third power, and then we have x minus 2. All right, so what I'm going to do is do second graph to look at the table, and then I'm just going to arrow up to when x is 0, and I see the y value is 18. So that's the ordered pair. You could also just hit the graph button, and it'll graph the parabola or the polynomial. And then if you hit trace, it will allow you to input values, and it's already on there. But if I just hit 0 and then enter, it'll show me a y value. And if I wanted to know any other value, say if I knew x was 5 and I wanted to know that value, it'll give me the y value there as well. So the degree was 6, and the y-intercept is 0, 18. Oh, it already has the close parentheses, so I don't have to do that. All right, so that should be it for part 1. Okay, now part 2, we want to find the x-intercepts at which f crosses the x-axis. So remember when we were looking at the notes section, it crosses at odd powers of multiplicity. So this first one has an even number, it will not cross. However, the x minus 1 has an odd, and the x minus 2 is understood to be odd. So it's going to cross at 2 of those zeros, and Now we want to know what they are. So notice that these are in the linear term. So what you want to do is do x minus 1, each of those terms, and set it equal to 0. X minus 2 and set it equal to 0, and then solve for x. So if you add 1, that gives you x equals 1. So the actual 0 is x equals 1, and it's opposite sign. And then over here you would add 2, and then that will give you x equals positive 2. So the zeros are actually the opposite sign, but when you put it in linear factor, this is what it looks like as a linear term. So the X-intercepts are 1 and 2 where they cross. Okay, your answer is incorrect form. You have one more opportunity. So I guess they want me to put it in, yeah, ordered pairs. I'm sorry, I didn't see that. Express your answers ordered pairs. So I want to put this as an ordered pair. So 1, 0, and then over here I want to do 2, 0. So be careful to see how they want you to input it. All right, and then part 3, it says find the zeros at which f flattens out. So remember, it flattens out at any number greater than 1. So it's going to flatten out at the x plus 3, and it's also going to flatten out at the x to the third. So it's going to flatten out at 2 different zeros, and in the same way we're just going to find out what makes each of those terms 0. So we have x plus 3, set that equal to 0, and that will give you x equals negative 3. And we have already done that for the x minus 1, and we got x equals 1, and we did that one. So negative 3 and negative 1, but again we want to put those in order pairs. So we will do negative 3, 0, and then we will do positive 1, 0.